Hi, my name is Tim Lindquist. I'm a professor in the software engineering program at ASU, and this is a video supporting our course SER423 on mobile applications. The content or the subject of this video is doing databases and actually external storage, external and internal storage, persistent storage on the Android platform. The material for this session is actually Unit 8 on the class schedule. Unit 8 covers Android only and looks at using Sqlite databases in Android apps, which is the predominant way of storing and persisting data. In other words, when your app shuts down and has to come back up again to have data available for your app, database is the most common way to do that. Like every other system, there are files that are available, but the files tend to be less useful for mobile apps than using a database. So there's some sections out of the Murphy text which are good, and I hope you'll take a look at, but there are also a couple of links to Google material. The first one of those from the class website is called Storage Options. And I hope you'll take the time to go through that. It's actually a very well organized section that talks about the different ways of persisting data, getting access to that data, protecting that data. The first topic that they cover are shared preferences. I'm not going to talk about that today. Actually, that's going to be covered in a later section. When we take a look at providing settings, we'll see that shared preferences, accessing the app's shared preferences, is the way to get a hold of values that the user sets into settings. It also talks about external device storage and internal device storage, and how to distinguish which of those you should be using. External device storage can actually be an SD card, or it can actually be a separate partition within the system storage area. Either way, using external storage is primarily aimed at sharing data with other apps or making data available to the user. So for example, if your app produces data that you'd like your user to be able to access through USB or other mechanisms, then in fact the right way to do that is through external storage. And the protections are set appropriately based upon whether you're using internal storage or external storage. Internal storage is available only to your app and only for your app, and consequently no special permissions are needed in order to write to that storage, and it's protected from other apps being able to access it. It's actually stored, we'll see in a few minutes, it's stored in a special folder within your app's home directory. So again, I encourage you to go through this. Forget about shared preferences for right now, but internal storage, external storage, and then we're going to talk about databases, go through an example of using databases. We've already talked about one aspect of a network connection that certainly has to be considered as a way of persisting, to store something in the cloud, for example, and then later reference it. Most of that we've already covered, although actually in the next link there's some more information that I think that is really good covering that, and that is connectivity in the cloud. This stuff I wasn't sure whether to put it under the networking section or under the persistent section, but we already had a bunch under networking, so I put it in here. Connectivity in the cloud, this actually talks about using the cloud and the ability to connect devices either through Wi-Fi or cellular, pardon me, when it's a cell phone or a smart device. Generally it has both 802.11 wireless and also cellular through some provider. You have a choice in Android of whether you want to ignore the mechanism that's used for connectivity or take advantage of it, detect what it is, how the connection is actually formed, and be able to use one or the other. So typically the bandwidth over cellular is less than the bandwidth over Wi-Fi, depending upon connections and so forth. And for some applications, some network activity may be more appropriate to use over one of those two than the other. Android makes it very easy for us to tell which one. This section also talks about creating peer-to-peer connections and also doing network discovery. So network discovery would be appropriate to find any other devices that are on your local area network and make a connection to them or to advertise services to them. So for example, gaming application would be a good example of that, to be able to discover who else is near, proximity-wise near, and be able to connect with. So service discovery is covered there. Both platforms, both Android and iOS, have mechanisms for doing that. On iOS, it's called Bonjour. We're not actually going to take a look in detail at either one of these. They'd be a very interesting topic for an advanced study or for another course. Peer-to-peer connections are, instead of accessing a server, it is an app that communicates with itself when it's running on different devices, for example. That would be peer-to-peer connections, where you have two devices that are able to communicate with each other. Typically, it's through peer-to-peer networking as well. And those connections actually can be formed in a different manner, and that's described in this section as well. So I encourage you to go through the material in both of those, follow the links, for example, service discovery, and read about that. It's actually very good. How to register your service, how to discover services that already exist, and how to connect with the services that you do discover, and how to remove your registration as well. So what I'd like to do is to talk about database in more detail, and actually to the level of actually doing app development in database, and to support that, here's an example. In the student course database, it's a jar file or a zip file, and what I'd like to do is to kind of base the rest of this video on a discussion of that. So I'm going to save it. I think I might already have it, but that's all right. And then let's go ahead. I want to show you how to access this one because it's a little different than the other examples that are published on the site. So the jar file, student course database.jar, and when you extract it, however you choose to extract it, double click on it in the Finder or My Computer, depending on which platform you're in, or if you're a command line person like I am, just extract it from the terminal. And if you change into the folder that it creates, you'll see that it has two subfolders and a readme.txt file. The readme.txt file essentially says this is not, this folder is not an Android application. You'll find two different things here, and let me explain to them. One of them is an Android application. The folder called Student Course Sqlite App is an Android application that demonstrates using a database. And then the other folder called Student Sqlite3 is an example of how a very common way to approach doing databases in Android apps. And that involves initializing, have an initial database that gets loaded with the app bundle itself, the .apk file, so that when the app comes up and is installed on the device, it has some initial data to work with. And that's a very common approach. What we have to do in that situation is to copy it into a region where we can have access to it and write to it. We can't write to the bundle itself. The bundle is read-only, and matter of fact, it's formatted in a special way that we looked at in a previous section. But in order to have initial data, we could either embed that data within the code and create the database that way through actual Java statements that construct the tables that are necessary in the data and initialize those tables. It's a little bit more efficient to actually create the database separate from the app, included in the project and in the deployment of the app, so that it actually is part of the bundle itself, so that when it gets installed, it's there and the app can access it very efficiently. So this second folder shows you how to do that with Sqlite. This is kind of a simple example, same one, or very similar to the one that we've used for networking. When you look at this folder, you'll find there are three different files in it. CourseDB.db. Sometimes .db is the file extension that's used for a database file. Other times you'll see it as .sqlite. And then there's a sequence of SQL statements, SQL, the query language for relational databases that exist in this init course database.sql, and a readme.txt file. So I encourage you to take a look at the readme.txt file. And let me just bring it up here. In the readme.txt file, it shows you how you can, from a command line, manipulate a Sqlite database, and it also demonstrates, if you haven't taken a course in database or read on a database yet, it illustrates on the database that's included certain SQL statements that you can use on the database that's contained inside of this file. So let me just show you as an example. You can install on your system, doesn't matter whether it's Windows, Mac, or Linux, an executable for Sqlite, and then access it from the command line with the name of the database. All right, so Sqlite3 course database, and now we're able to access any of the data that's within that database. So I could say select star from student. So student is a table, and you can see when I select star from table, it gives me all of the entries within that table. In this case, we have, let's bring it up here. So in addition to the readme.txt file, which I encourage you to look at, there is an initialization. So if you need to go back and reinitialize, this kind of shows you one way that you could initialize a similar sort of a database. In this particular case, we have 3 different tables: a student table, a course table, and a student takes table. The student table has a name column, which is text, a major column. It has student's email, and then it has an integer number for the student, or student ID number, or whatever that would be, it might be. And then it has a primary key. We just call it student ID. In the course table, there's the name of the course, and then just a primary key for it, which is an integer ID. So we're not keeping, obviously, the same information that you'd normally keep, but nevertheless it demonstrates those two. And then in order to represent a relationship between the student table and the course table, for example, a student takes a certain number of courses, different courses, we use a student takes table, and that really has only 2 pieces of information, a student ID and a course ID. This notion of it being a foreign key, and the key that it references, as well as on delete cascade, some topics that you may cover in a database class that essentially provide additional semantics for manipulation of student takes data, meaning that if you delete a course, then in fact you remove all of the student takes that reference that course, and the same thing for students as well. So in addition to that, within this init course db.sql are inserts. These are SQL statements that insert data into the database to create an initial state for the database, and that's, you can see that's what we just looked at. So insert into the student table an entry for Tim Turner. I guess there's the name Tim Turner, Harry Holmes, and also Sam Smith. And then some inserts into the course database and so forth. So from the Sqlite command line, we can access information using any of the SQL statements. So we can do inserts, we can do updates, we can do deletes, and so forth, any SQL statement. The readme.txt file actually shows, as I mentioned, several of the common selects or SQL statements that actually you would need to use in order to do the laboratory example in this case. Yeah, we're not doing the laboratory exercise is not to do a student database, but it is to do a database for geographic locations and routes that are made up of geographic locations. So in that case, you may have 2 different tables, one for places, another one for routes. And then a relationship between them. So this shows you the typical SQL statements. So here's a select statement that goes across the 2 tables. Here's an insert statement into the course table. an update in the student table, and so forth. Insert. And it also discusses the meaning of the cascade statement that's in there as well, and the ability to, in SQL, create a table. So if you chose to not initialize your database with a database file in the bundle, you could actually execute from Sqlite the creation of a new database and create those tables and do the inserts in the exact same way they exist in this init course database.sql. So what I did in order to construct, but I didn't do that, what I did in order to construct this example was to create that database as is shown in the readme.txt file, initialize it with the init course db.sql, and then I pulled it into my Android project. So let's take a look at that Android project, because I want to show you a couple of other things relevant to that. .quit to get out of SQLite. And let's go ahead and start up Android Studio. And within Android Studio, you can see in my project, once it gets fully up here, within the project, I have nothing special in the manifest to access the database. So actually what I'm going to do is to copy the database into internal storage. And then there are just two classes that are associated with it. One of them is course DB class, and the other one is the main activity, which is the controller for the only view in this project. If you look under resources, in fact, under raw resources, so in Android Studio, you end up having to create the raw folder and then create the file course db.db within that raw folder. And that's simply the file that I showed you in the other folder, the initialized database. So let's look at, let's actually go ahead and get this thing running on the emulator. And then we'll talk about, so you'll see that the database is actually being used. In this example, we don't access the database. We do access the database on the main or the UI thread. There you'll find in some of the literature where it indicates that there are certain database operations, even using SQLite, where they take enough time that you may want to access them off the UI thread using a mechanism like the async task. Creation of a database is one of those sorts of activities. So here is the single view activity that comes up, and you can see in this case, the student Tim Turner, his major is software, his email and his student number. And then there are a couple of drop downs, so we can take a look at different students and the information for those students. And we can actually add information as well. So what I'd like to do is to show you, so let's first, you can see that I don't have full functionality here. I don't provide the ability to add new courses. You can add a new student, but before we do that, let's go ahead and take a look at what happens within the course DB and the main activity. So let's first look at the main activity. And in the main activity, on create, you can see we provide reference to each of the different components that exist within the view. The button, the add button, the remove button, the edit texts for the name, major, and email, as well as for the student number. And then we have two different spinners, one for the student names and then the other for the names of the courses. So this load fields, set up the spinners, student spinner, and load the fields, actually take care of setting things up for us. And let's go down and take a look at those. We'll see the first example of using the database. So within the setup student spinner, you can see we create an instance of the course DB class. We have to pass it, in this case we're passing it the activity, which is a context. That context is used in order to get access to the paths for deciding where to put the database. And then we create a Sqlite database object. Sqlite database is part of the Android API. So it comes from, let's go back up here and just take a look at the import. There it is right up here. Import android.database.sqlite SQLite database. So if you look at the package Android database SQLite, you'll see that there are several classes that are defined in there that allow you to define and manipulate SQLite databases. So now back down here to our first access. And we're doing it in a simple way. There are other ways to access a database, but once we have a handle on the database or a Sqlite database object, we are doing a raw query, which is nothing more than a string, which says select all the names from the student table, and then there aren't any arguments to substitute into that query. If I had, for example, if I wanted to select a single student, I may say select name from student, or maybe select email from student where name equals, and then I would have an array of arguments that I would pass to it. That's exemplified in one of the other queries within this example. And when I do a select that may return multiple values, it creates a thing called a cursor for me, and I can go through that cursor in an iteration and pick things out of the cursor. In this particular case, since I'm only selecting one value, I could say select name, comma, email from student, and then I would be bringing back a cursor that had multiple values in it. I could get a hold of those values by accessing the cursor. Cursor.getString of 0 would in this case give me name. Cursor.getString of 1, if it was name, comma, email, then cursor.getString of 1 would get me the email. All right. So in fact you can see what's happening here is I'm adding to an array list all of the names, and then I'm going to go ahead and make that array list into an array adapter and make that array adapter the adapter for the student spinner. And that will give me the drop down that has all of the students' names in it, all right, which is this one right over here. Okay, so now that's one thing, and I'm not going to go through and read all of this. I think that's pointing out enough that you can see how things work. I do want to show you another aspect of Android that is extremely useful. From the command line, there is available through the platform tools that come with the Android software development kit, a platform tool called the Android Debugger. And you can see I've placed that, if you're a terminal person, you can see I placed that into my path, meaning that I can invoke that tool. And it has in particular one capability, ADB shell. So when I invoke a shell, what happens is I end up making a connection, in this case to the emulator, and running a shell on the emulator. So now what I have going on the emulator, on the emulator, all right, on this Android device, I could actually connect to a physical device. If I had a device that I was using for debugging, I could do a shell on that physical device. But once I'm on the device, then in fact I end up as root, and I end up in the root directory. This is one of the reasons why you only want to enable debugging on a device when you know that you are the debugger and no one else is going to be messing around with your device. But within this device, I'm in the root directory, and you can see these are all of the folders within the root directory. In particular, we're interested in the data /data directory, or data users 0, user 0. And in the user 0 directory, you'll find a subdirectory. If you're a Unix person, you know that each of these entries are files or folders in this case. I know that this is the name of the folder, edu.asu.sidc.se, Lindquist Student Course SQLite. That's the app that we're currently running. The fact that there's a D over here on the left-hand side indicates to me that it's a directory or a folder. So let's move within that directory. And if I do a directory, or if I do a listing within, so now I am within the home directory of this app. Every app that you install on an Android device has to have a unique package name and name for the project, package and project name. So I've highlighted in blue an example of that, the Echo Client Android, which is one of the examples from the networking section. So that in fact a home directory gets created for that app once it gets installed, and within that home directory all the files are kept that are in internal storage for that app. So if I look within the files directory, you'll see there's my course database. All right, so remember that I'm logged into the emulator. And within that emulator, I now have access to the Sqlite program, Sqlite3 course database.db, and there it is. And now I can do the same select, star from student. And you can see I've already added Tim Lindquist as a new student. Let's go ahead and add somebody else and see if they show up. George Williams, who is a CS major, and George at asu.edu, and his number is 1034. So let's add. All right, so now you see George Williams shows up in the drop-down, and I can navigate to George Williams and his information shows up. But just to show you, now if I do the same select statement, you can see that George Williams shows up. So why is this useful? Well, it's particularly useful not only for database, right? For any kind of persistent storage that you may be writing on the device. You can obviously access external storage as well as internal storage. But when you're doing a database application, it is very helpful to be able to query the database directly on the device to see exactly what's happening with a SQL statement that you've executed. I can't tell you how many times that you end up having the column name wrong, or you end up putting the right information in the wrong place, and having the ability to log into the emulator and or the device and debug the database by querying it through the Sqlite program makes it extremely useful. All right, so I'm going to leave it at that for this section. Again, oh no, there is one other thing we need to look at, and that is the following in the course DB. All right, this code is a mishmash, but it does show you the basis for creating a class that accesses whatever database that you might want to use in your app. Notice that it extends Sqlite Open Helper. That Sqlite Open Helper provides several methods that do exactly that, help you access a Sqlite database. And it's very common to extend that class and override methods that are in it by adding additional functionality to it, or by just doing separate methods. So in this particular case, there are some of these that don't get used. Create database, check database does get used, but let me show you where it gets used. Copy database, open database. We saw from the app that it calls open database. And open database uses a local method called check database to see if the database has already been copied to our local storage. So remember, our local storage was this quit print working directory. All right, so we ended up putting in data user 0. We didn't, yeah, we did actually. We did it explicitly from within the program. Within our home directory in the files directory is where we placed the coursedb.db file, and that is done by the method here, copy database, right? So when an app is first installed, you want to check and see if the database already exists within the files directory. If it does exist, that means that the app has previously been installed and there may be user-specific data in there. You don't want to copy your initial database over that user data. But if it's not there, you don't want to really access it and try and write to it. You can't write to it you can't open it up for write access in the bundle, so you want to copy it to the bundle. So the logic is within this class. In the open database, it's actually not very efficiently done here because this class demonstrates some other types of access. It looks to see if it's there, and if it is there, it actually does an open to it, and it queries to see whether or not tables are there and so forth, just to show you how to do that stuff. You would not want to take this class as it currently is and use it in a real application. On the other hand, for instruction purposes, it's actually a worthwhile thing to look at. But anyway, when you open the database, every time you open it, it checks to see if the database file is there. If it is there, then in fact, it doesn't copy it. But if it's not there, it says, oh, this is the first time I've been executed since I was installed, and consequently, I need to copy it to my internal storage. All right, so let's leave it at that. So this again has been a section on Unit 8, persistent storage for Android using SQLite databases.